whatever we apply FOPRO, always the same direction of water flux and salt flux. Major purpose of operating FO process is to get what? FO? Why your soul is going, thinking about your second life. So what is the main purpose to operate? What is the main purpose of operating FO process? To generate urine? No, FO. For osmosis. There is a methodology, but final goal of operating FO process is to water production. Water production. What does it mean, J?
Flux.
J is flux. What is a flux? Water. To get water. Yeah, same over out. Yeah, but what is benefit? To get the water from this process, what is benefit? Low energy consumption. Theoretically, only theoretically. Because this is photosynthesis. Okay. How about the PR rule? Okay. Yeah, I explain this. So in the membrane, there is the salinity level, osmotic pressure level. How about the field solution? This level. So we can say this is osmotic gradient. Yeah, gradient. Let's say yeah. So I said in case of FO is JW. So main purpose is water production. Yeah, JW is KW NDP. What is NDP in here?
Y minus Y.
Delta phi and delta P. Reverse osmosis. Yeah. And KW cancel out. For osmosis doesn't have any step pressure. Yeah, here. So what is delta phi is osmotic gradient is equal to this guy minus this guy. Yeah. Yes. We can say like that. This is osmotic gradient. So to keep the target amount of J, we have to keep this osmotic gradient. Yeah, we have to we have to do our best to keep this osmotic gradient to get fixed value of JW as long as we select two different water solutions for the true solution and feed solution. When you decide this, we calculate osmotic gradient, but we have to do our best to maintain this osmotic gradient. Why? This is that driving force. Yeah, it should be always maintained this level. Otherwise, it decrease. The JW value is lower. Yeah. But whatever we apply the membrane-based desalination technology, we need to think about this bad the phenomena. We call this concentration polarization. What is happening? Yeah, concentration polarization. So here, so maybe osmotic gradient level like this, but the JS we have reverse salt flux. Yeah, reverse salt flux. So that in FO membrane case, to minimize this, okay, minimize and the concentration polarization minimization, we place this active layer here. This is active layer. Facing is the solution for FO mode. Why do we need to face the active layer facing the feed solution side for FO mode?
So some particles of the water will remain in the
Yes, minimize coming in, yeah, to the solution. Because water flux moving low to high, that is coming. Yeah. So if we face the active layer facing feed solution side, we can minimize internal concentration polarization. But the PRO case, we can place the active layer. But PRO case, we add the active layer this side in PRO mode. In case of PRO mode, we add the active layer this way. But not different. In case of FO, JW and JS is the same direction. Why we need to position active layer facing dual solution side in pure mode? Sorry? You studied the other class? Oh, excellent. Why? FO PRO, same direction of JWJs. Why we have to the position active layer through solution side? What is the big difference between the FO PRO? You said we add what? Pressure. PRO has here the different. This is FO case. We need add one more. Yeah. This is PRO case. PRO case. We can give you a question. Doctor, you said F4 only has a final purpose of water production. How about PRO? PRO has JW. For different equation, adding one more delta P. Yeah? In blue solution side, like FRO. For RO case, delta P always should be higher than osmotic gradient. So that's why water flux is opposite. Yeah? RO case. But PRO is not exceeding osmotic pressure, even though we give the pressure to the solution side. But they have flux as well. Why PRO should not be designed for water production? That's my question in your exam. Why? Does anyone know that? Anyone? FO is designed for getting the water, like reverse osmosis. PRO, all direction is the same, principle same, except only one thing, applying the pressure to the solution side. But PRO, I give you answer first. PRO should not be designed for water production.
Should be used for energy.
Yeah, energy.
Yes, but I think because
Yeah, energy. Everybody know.
Yeah.
Why should it not be designed for water production?
I think it
More advanced chemical, yeah?
it takes too much time to like,
Sorry?
I think it takes too much time to
No.
high cost.
Yeah. So whatever I ask, what is the related cost? Yeah, you're right. You're right. But they have JW, baby. Why we cannot use this JW flux for water, produce the water? Why?
The pressure because it's opposite to the
This is hint. This is another question. Your final exam. Now review time actually. Review section. You will see. I ask you why PRO should not be designed for water production. Please explain. Use this diagram. I give you, X and Y. You can explain how. Okay. So X is external pressure. Y is flux. Yeah. Without any external pressure, we get flux. Negative positive, only the direction difference. Yeah, but we can put here as well, whatever, any position. But important point here, without any extra pressure, we got the water flux. This is FO. Yeah? No extra pressure applied, but we get, yeah, no extra pressure, we got flux. This is FO. Everybody agree? Yeah. But we start apply extra pressure as increase more, yeah, until not exceeding the point, not exceeding osmotic gradient. This is mode related to what? Pressure without osmosis. We added the pressure here, but not exceeding osmotic gradient. If we exceeding the osmotic gradient, what's going to happen? If we add extra pressure in the solution side, exceeding
Reverse
osmotic,
osmosis.
reverse osmosis. Yeah. So that's why reverse. Yeah. It started the flux is reverse. So that's why reverse osmosis. But we start to get flux as well, but different direction. When you apply delta P higher than osmotic gradient, water flux it changes. Yeah. From here to here. Yeah. So that's why at the center point of zero, upper and lower is different water flux direction. Not related to plus and minus. Only the opposite of water flux direction. So, so I give you one more question. The same question. What is your answer? Why PRO should not be designed for water production?
Good. I will.
Yeah, so you can write down your final exam. I already explained. What? When you apply more pressure. Yeah, see. So I have a cork here, more pressurized. We think when you open, more powerfully spreading out. Yeah. We have to conclude anyway. After getting more practical answer. Yeah. Yeah. But what's going to happen? When you increase more pressure until osmotic pressure, how about water flux? Water flux is increase or decrease? Decrease. Why? Why decrease?
The gradient between the
Minus
the
P. We see more pressurized. We give more delta P. It give more power. Everybody agree? Yeah. More increase the drive and power is increased. Okay. But how about water flux? Decreased by, according to equation, is minus delta P. Is over the time the jet flux is decreased. So it's not good for water production. Steroids, yeah. So what is best? To use that power generation. So delta P, I mean this Y axis is power density. They give you power density equation. The voltage is square value, so that's why they show the same circle. But we can have to know that more salinity gradient, more salinity gradient, we apply the more high salt water, like our what kind of water in Jordan? Dead Sea. Will increase more, yeah? When you use the fixed one, we can increase more the solution. Seawater, out of brine, and salt lake, and Jordan water. Yeah, Dead Sea. More salinity gradient, give more power. Yeah, when so give more power, but maximum value can be reached only half of osmotic pressure. There's the other question. Okay, you can do, you can give power as maximum you can do, but it's not guaranteed the maximum power generation. Only power half amount of osmotic gradient. So, osmotic gradient according to the equation. Okay? But that value, osmotic gradient should be highest. Yeah? But applying the pressure should be half of osmotic gradient. Everybody agree? More osmotic gradient or the flux, they gives energy and but apply the pressure, regarding the pressure, they should give only half. Are you with me? So, PRO case, yeah, PRO case, there is an active rate here. So, the feed solution has organic or salt. So that's, they decrease like this. And actually, this osmotic gradient reduce this amount, reduced by this amount. We call this effective, effective osmotic gradient. When you look at the diagram, PRO mode here, yeah? Active layer facing, and initially the value is this, and they give this amount, ideally this amount, but facing the membrane, this value, ideal value is decreased this amount by concentration polarization. But feed solution, okay, the concentration increased inside the membrane, we call this concentrative internal concentration polarization. How about FO? The active layer facing feed solution side, and the osmotic pressure decreased from through solution side because it's open channel. Open channel. You know, active layer is at the cross layer is at the support layer is cross, open. So that is dilute from highest value of osmotic. Yeah. So in Apple mode, in porous layer, this is a dilutive concentration polarization. Apple mode is concentric internal concentration polarization. But concentration polarization is the same, but in a different concentration accumulation. This side is concentrated, this is dilute. But anyway, same happening. So when we place these two this way, we can get this diagram. Again, when you understand principle only, so whatever you have a diagram, it's easy. Yeah. So this is true solution, and this is a feed solution. Active layer facing the true solution. This would be maybe pure mode. Yeah, pure mode. So that they apply the pressure here. Yeah? Pressure. So ideally, they have to have this amount of osmotic pressure, but due to the concentration polarization, actual this value is would be decreased, giving this actual real the effective osmotic pressure by concentration polarization. Okay, but natural happening. Natural, whatever you apply, as already you select the feed solution, true solution with any types. Ideally, this amount is total osmotic pressure, yeah, osmotic pressure, but in pure case decrease with this amount. This take place always actively, yeah. But how about the Apple mode? Apple mode case is decreased in here, yeah. Once the Apple has active layer facing the feed solution side. Okay? So I can give you a question like that. Why Apple PRO has a different displacement of active layer? You can explain it. Yeah. So this is related to how to make a membrane, and when apply the fabricated membrane to actual the mode Apple PRO, whatever, we experience the concentration polarization. I already explained all over this, and how? Yeah, we understand the natural happening, concentration polarization. So how can you minimize? How can you minimize the loss of this NDP? How can you minimize? We have to, do our best to maintain osmotic gradient. So we can develop membrane. Our saying, yes, to minimize fouling scaling, even though our membrane is cheapest, we have to develop membrane, yeah? That is related to cost, yeah, of packs. OPEX cost would be the same answer, but the practical answer, the consequence, the result of having that kind of phenomena. So we have to develop membrane like the F4 membrane. Whatever the have a question regarding the F4 pure membrane, you always call this guy. Yes? What is the S? Superman.
Support.
The membrane structural parameters. Yeah, membrane structural parameter S. So always, whatever you make membrane, pure membrane, you do your best to have the low value of the S value. So how can you get the low value of S? Yeah, this value should be low, this value should be low, this value should be high. What is the tortuosity? Tortuosity means, what does it mean by tortuosity? Tortuosity means, water pathway length from beginning to end, destination. Yeah? The membrane has a support layer that the thickness should be low. The L means total membrane thickness, including active layer, support layer. Whole membrane layers should be thin. Okay? And how about porosity? Porosity should be increased. How can we increase the porosity of synthesized membrane of either the F or pure membrane? How can we improve? Mostly, we use the case inversion web process. Okay? For porous support layer. We learn same of support layer of R and M, yeah? Which can be used for F pure as well. Everybody remember? So how can you minimize? We apply different method, electroscreen. We learned that in chapter 5, electroscreen. They make the scaffold porous and choose we improve the porosity. So that minimize the loss of salinity gradient, providing initially the calculate value of JW. Okay. So the other way, we are not focusing the membrane, so we can have somehow minimize concentration polarization, focusing on water. In the solution side, water solution side. In the membrane side, we can follow that, and beyond the membrane side, we can apply the pre-treatment. Same of our to minimize the reverse osmosis fouling. What we have to do? Yeah, we add the top and UF system. The same question of the second exam. Yeah, we can apply the top and UF minimize biofouling. So that's why we don't need to add actually chlorine. Okay. After applying chlorine, what's going to happen? They make another bad side effect like AOC, 300 method that affect the ecosystem outright, and the other is make an environment for microorganisms to survive again, giving a biofouling. Mostly originally not expected biofouling because we have a state of art treatment, yeah, to remove microorganisms using the DAP and ultrafiltration. Same over the FOPRO. So we can apply pre-treatment, the draw solution or final solution. Otherwise, once we observe the caking accumulation on the active membrane side, we apply the Bevasin. Yeah, Bevasin. Okay. Oh, I jumped a lot. Yeah, Bevasin and yeah, Bevasin. So the other way, anyway, the other way is apply the nanoparticle addition, the membrane side. Sorry, I jumped too much. Okay, concentration polarization mostly related to salt. Salt dissolved in feed solution and to the solution side. Yeah? How about microorganisms? Microorganisms always give fouling. Yeah? They makes more serious the decrease of salinity gradient again. So when you go back this slide, when you go back this slide, yeah. So ideal osmotic gradient is valued, but by the internal concentration polarization, actually ideal value decrease with this value. This is actual effective osmotic gradient. Only this value is contribute at JW. Okay, but we have microorganism. If we have microorganism, what's going to happen? In feed solution side, microorganism there, they create EPS. Yeah, there's the same question of the second exam. How can the mechanism asking you mechanism to degrade our membrane? Yeah? So if we have an organism creating the EPS, extracellular polymerase substance, that has some oxidation capacity. They sticky and they degrade the porous membrane as well. Yeah, this contribute a lot of the salinity gradient decrease. This is the original value and this is decrease. But normal concentration polarization leading to have this amount osmotic gradient from ideal value. But if we have a biofouling, more decrease. Yeah, that's why it will be not good. Yeah, critically, well, yeah, more addition, more concentration polarization, even membrane degradation in process. Support layer, yeah, support layer, because support layer is porous. Yeah, more decrease. So how can it be minimized? And we can develop the some support layer or active layer, minimizing the microorganisms to be attached to the surface. How can it minimize? The concept is similar of our, okay? Back to the URI's class, okay? You always go away. Okay? Like the outer membrane, we can apply the nanoparticle having a biocide capacity. What is a biocide? Biocide means side is clean. Suicide, CIDE, suicide. Side means killing, bio-killing. What kind of material can contribute? Biocide. One example is silver nanoparticle. Why can the silver has capacity of killing microorganisms? In the Eastern Asia country like Korea, Japan, China, they has the emperor dynasty, and even like the Middle East. And our food style, eating the soup, yeah, tom yum soup, like a tom yum soup, whatever, and rice. There is a starting key setting, and we can eat some side dish. But there are many conspiracy to kill the king. Yeah, so always scary. High position always have tension to be scary. Killed by other attack. So even food, and they had already put the secretary, and they testing everything. And then it's fine, and the king started eating. Otherwise, they use a different spoon. What types of spoon do you use? Can you guess? Silver spoon they use. Why they use a silver spoon? Can you guess? Whenever they had poison, whenever the silver is exposed to poison, the color is changed. The color is changed. Silver to dark color. We not immediately. Yeah. In other words, silver has a capacity, oxidation capacity to kill microorganisms. So that's why they lose the electron. Their color is changed when they reach the bottom energy level. Physical, chemically. Okay. So that's why color is changed. electron rich to electron poor. Okay, let's change. So that's why we can use silver to minimize the microorganism fouling. Another material like the silver is now price is increase, should increase. Yeah. So we cannot add this like cost issue. Yeah? The other way is same role of silver is graphene oxide. Do you know graphene oxide? Do you know graphene? Do you have a pencil? Graphite based pencil.
What? Graphite is graphite.
Oh yeah. Why you he don't want to give me?
Đi làm sao một lấy nó giả được.
Oh, this is important.
You
You have all exam.
want to get from
So this graphite, yeah, carbon mass. Okay, this is graphite. Maybe 20 years ago, I know, 15 years ago, one scientist has a Nobel Prize like this. I'm not joking. Very easy to get Nobel Prize. Go home and try like me. Try. Do you have a scotch tape? Scotch tape? No? If we have scotch tape, yeah, so we maybe, oh yeah, my hands is scotch, yeah, already. So when you observe microscope, this guy, layer, the layer is different. This is a one-dimensional layer.
But you have to do it again and again.
Yeah. And one-dimensional sheet graphite structure. Layering. This is graphene. Why we have to use very good conductiveness in our material, electronics, whatever. Very cheap. He got Nobel Prize. And how about other scientists? After he announced this discovery, many researchers mix like orange juice mixer. They actually put more fast, layer by layer. But no Nobel Prize. Some guy used ultrasonic. So I get this graphene oxide, one-dimensional. How can I apply? If I put this graphene oxide in the oven, oh no, don't think about my hand. Anyway, graphene. When you put the graphene in the oven, there is burning under condition of
I'm really comfortable, man.
I forget. Yeah, when I put the graphene into the oven under oxygen condition atmosphere with the heating, they change the graphene to graphene oxide. Oxide means they can absorb the moisture. Okay, H2O. They make hydrophilic. Microorganism hydrophobic. Yeah. When you apply the very cheapest graphene oxide to membrane, even the active layer or force layer, yeah, they provide the condition of hydrophilicity and biocide effect. Would be good rather than the silver nanoparticle, which is very costly. Everybody agree? Yes.
You need this one? I need to give it with me. It's Dr. Shen.
When I give a question, how can he minimize biofouling induced concentration polarization? I already asked you keyword, yeah? Don't try, especially you, don't try like this. This is the answer. This is the answer. We have to apply this.
I read too much.
Yeah, graphene oxide, okay? Graphene oxide.
How can we rewrite what?
We can apply the biocide nanoparticle like silver or graphene oxide on either the active layer, even porous layer. But we applying this material nanoparticle into both sides is very hard, challenging. So many researchers apply the only either way, okay? Because they relate to very are very hard to optimize making that kind of membrane. Anyway. So you understand concentration polarization by salt is decreased. When you have a biofouling, more decrease. How can you minimize? We can use the biocide effect nanoparticle to that membrane side. Other way, we can treat beyond the membrane side. We can apply the treatment process to treat feed water, and I already mentioned improve the structure parameter of the membrane. The other way, when you observe the case like this, regularly we can apply to cleaning, chemical cleaning, to remove the accumulated salt or microorganisms. Any question? Very easy, yeah? So remember, only this. Whatever you study, chapter 5 and 6, you, if you can draw by yourself, yeah, explain to yourself according to the principle, key principle, you don't need to memorize. And you can need to write down J, okay, equation, what is driving force? NGP, yeah? How can you make it NGP? Okay. Develop the membrane and treating something, and develop the membrane cell, following the this S, getting a low value, stop. And this is a slide before the end, with the last slide. Uh, when you look at this, can you imagine what this diagram has about for us?
Evolution.
It's similar to our first page in chapter 1.
Yes.
Yeah, we started with the water recycle. Yeah?
Yes.
Water recycle. Same, yeah? Water recycle. But as a consequence, yeah, we in the natural water cycle in nature, nature is provide us different salinity level water. Simply river water and seawater, even groundwater. Yeah, there is different salinity. So we learn the PRO process in this chapter. When you apply PRO, giving a different salinity water, they can generate power. So, but how about evaporation? It's a natural happening. So if we apply engineer concept in existing PRO system, we can apply the distillation. So PRO and distillation combination completely mimic, yeah, natural the water cycle. Water cycle. So distillation means require the low grade heat. In the shell GTL, final stage apply the evaporation like the distillation. They have many ways to the low grade heat, and they use, yeah, in terms of energy saving, and they evaporate all out of ground, and they very clean water from evaporator like here, this side, yeah, this side, and concentrated salt remained evaporated system bottom. They collect and separate their own valuable element from the salt. Yeah. Also, the salt also contain water. When you try to separate high salinity, low salinity, provide a different salinity level of the stream. In the PRO system, when they receive this water, generate the power depending on the osmotic gradient. So cycle, completely mimic. You can add more idea actually. You can add more idea as long as you have some wisdom from your routine life. So that's why whenever you have a vacation, you have to go somewhere, India or China or Africa or something, Korea, where the mountain, or America, where there are a lot of mountains there, and whenever you inhale the air, so they give a idea from nature. So that's why Stephen Jobs always happy to visit India. That's why they observe the everything. He got the idea to make an iPad. iPad changed later iPhone. So sometimes you just study in the library. But I recommend whenever you have an exam, after this exam, you have to study another chapter from nature. So that's why I always recommend you go to somewhere with a mountain. Alps is very expensive. Okay, so yeah, do your best to learn something. So maybe you are a chemical engineer, whatever you learn, fundamental, you have to build your ability to change the fundamental to engineering concept. Yeah, some guy already senior. When you graduate, congratulations your graduation. Our exam is not finished yet. But I shared a lot of this. Based on this, I make the exam. This is our my review section. Any question regarding the review section on chapter the pressure impact
There will be
osmosis?
Java lecture next week.
We don't have any class next week, reading day, because I don't extend our the homework deadline. Homework deadline will be extended Tuesday midnight. Okay, what does it mean? On Sunday you have a quiz, yeah? The another class of the same room for junior, yeah, not senior, yeah. So anyway, it will be a good chance to come Sunday, Tuesday for reading day, means go to some lab and open the install the web program and solve together. Even our section not cover the chapter 5 web program. My question in final exam will cover the way based on my example of previous final exam, and you understand what kind of pattern we see. And so also ask me using the office hours. I'm still next week. My office you can visit whenever you have a question regarding the web program. Okay. So anyway, next week 2 class is reading day, not cancellation. Reading day. Okay.